Imagine you're flying through the universe. In every direction, galaxies, thousands of them. The universe is packed, alive, bright.
And then you enter a region of space where there is nothing. No galaxies, no stars, no gas clouds, no anything.
You keep flying, still nothing. You fly for 10 million light years, nothing. 50 million, nothing. 100 million, still nothing. 330 million light years of pure, absolute, impossible emptiness. This place exists right now in our universe.
It's called the Booties Void, named after the constellation it sits behind.
And the fact that it exists at all should not be possible.
It was 1981.
Astronomer Robert Kirshner and his team were doing something routine, mapping galaxies in a region of space near the constellation Bootes.
The map was filling in nicely. Galaxies here, clusters there, the familiar web of cosmic structure. And then a gap, a big gap. They thought it was an error. Rechecked the data, still a gap. They pointed more telescopes at the region, searched more carefully. The gap didn't fill in. It got bigger. By the time they published their paper, they had found a void 250 million light years across, the largest empty region ever discovered at that time. Kirshner reportedly said, "We have found the most remarkable feature of the universe." He had no idea how right he was. Our Milky Way is 100,000 light years across. The distance to Andromeda, 2.5 million light years. The Bootes Void is 330 million light years across. You could fit 3,300 Andromeda distances inside this void end to end and still not reach the other side. If the Milky Way sat in the center of the Bootes Void, our nearest galactic neighbor would be 165 million light years away. We would be utterly, cosmically alone. The night sky from inside the Bootes Void would have almost no galaxies visible, just darkness. The kind of darkness that has no name. And here's the thing that should disturb you most. The Bootes Void is not the only void. It's just the biggest one we've found so far. At any scale you look at it, the Bootes Void stands out, a hole that shouldn't be there. After the Big Bang, matter was distributed almost perfectly uniformly. Tiny quantum fluctuations created slight density differences. Gravity slowly pulled matter toward denser regions. This process takes time, enormous amounts of time. The universe has been structuring itself for 13.8 billion years. Computer simulations predict voids of a certain maximum size. The maximum the models predict is around 150 million light years. The Bootes Void is 330 million light years, more than twice what physics says should be possible. There are about 60 galaxies inside the Bootes Void, where there should be thousands. They cluster in a thin filament, like spider silk stretched across a football stadium. They're arranged in a rough shell pattern, as if something pushed them to the edges of the void from the inside, as if something cleared this space deliberately. The night sky from inside the Bootes Void would have almost no galaxies visible, just darkness, pure darkness. Kind of darkness that has no name. The first explanation? It's just statistics. Random processes sometimes create extreme outliers, but the probability of a void this large is so small, some physicists consider it essentially impossible. Void merging. Smaller voids form, grow, bump into each other, merge, creating larger voids over billions of years. The leading scientific explanation today. It works, partially. The numbers are still uncomfortable. Dark energy concentration, a region where dark energy is higher than average, pushing matter away more aggressively, creating exactly what we see. But this requires dark energy to be non-uniform, which contradicts our current models. Multiverse bubble collision. Our universe brushing against another universe in the early moments after the Big Bang. The Bootes Void as a scar from that contact. We cannot prove this, but the math works. And the theory? Nobody publishes. A Kardashev Type 3 civilization harvesting galaxies, leaving a 330 million light year void as a byproduct. Nobody takes this seriously in print, but nobody can prove it's wrong either. 5 theories. None of them fully explains the Bootes Void. The mystery remains open. The void doesn't care which theory we prefer. Wait, I said almost nothing. Not nothing. There are galaxies inside the Bootes Void. About 60 of them have been found. 60! In a region where, based on the surrounding density of the universe, there should be thousands. 10,000, maybe more. Those 60 galaxies cluster in a thin filament running through the void's center. Like a single thread of spider silk stretched across a football stadium. They look normal. They behave normal. They're just... And here's what makes astronomers uneasy about those 60 galaxies. They're arranged in a rough shell pattern, as if something pushed them to the edges of the void from the inside, as if something cleared this space deliberately, as if something is still here. Normal matter, galaxies, gas, stars, makes up only 5% of the universe. The rest is dark matter and dark energy. Dark matter doesn't emit light. We can't see it. We only know it's there because of its gravitational effect on visible matter. In the Bootes Void, there's almost no visible matter. But what about
about dark matter? Measurements suggest the void is also depleted of dark matter. Not empty, but far less than the surrounding universe. The void isn't just missing galaxies, it's missing the invisible scaffolding that galaxies form on. The scaffolding itself is gone. Whatever happened here happened at a fundamental level. The first and most comfortable explanation? It's just statistics. The universe is random. Random processes sometimes create extreme outliers. Flip a coin 1 trillion times, you'll get some impossibly long runs of heads. Maybe the Booty's void is just the universe's longest run of heads, an extreme statistical fluctuation that happened to occur in our observable universe. It's reassuring. It asks no uncomfortable questions. The problem? The probability of a void this large forming through random statistical chance in the current cosmological model is so vanishingly small that some physicists consider it essentially impossible. We're not talking about winning the lottery. We're talking about winning the lottery every day for 1,000 years in a row. Statistics can produce outliers, but there are limits to what statistics can do in 13.8 billion years. The Booty's void appears to be beyond those limits. A more sophisticated explanation. Void merging. Smaller voids form naturally through standard cosmological processes. As the universe expands, these smaller voids grow. They bump into each other. They merge, creating larger voids. Maybe the Booty's void started as several smaller voids that merged over billions of years into one giant supervoid. This is actually the leading scientific explanation today. And it does work partially. The structure of the 60 galaxies inside the void is consistent with multiple merged voids. But, and this is a significant but, even accounting for void merging, the models struggle to produce something this large in this amount of time. The explanation works in principle, but the numbers are still uncomfortable. It's a satisfying answer that doesn't fully satisfy.
Dark energy is the force driving the universe's accelerating expansion. We don't know what it is. We can't see it. We only know it exists because the universe is expanding faster than gravity alone can explain. Some physicists have proposed that dark energy might not be perfectly uniform throughout the universe, that there could be regions where dark energy is more concentrated, pushing matter away more aggressively. If a region of the early universe had a higher concentration of dark energy, matter would have been pushed outward faster. Galaxies wouldn't form. The region would hollow out, creating exactly what we see in the Booty's void. This is an exciting theory, but it requires dark energy to be non-uniform, which contradicts our current cosmological models. To explain the void, we might have to rewrite our understanding of dark energy itself. The cure might be more unsettling than the disease.
Now we enter territory that some physicists find genuinely exciting and others find deeply uncomfortable. In some versions of cosmological theory, our universe is not alone. It exists as a bubble in a larger multiverse, an infinite foam of universes, each with their own physical laws, each expanding independently. Occasionally, in theory, two of these universe bubbles collide. Such a collision would leave a mark, a region where the physics of our universe was disturbed, where matter behaved differently during the early universe, where structure formation was suppressed, creating a supervoid. The Booty's void in this theory could be the scar left by our universe brushing against another universe in the early moments after the Big Bang. We cannot prove this. We may never be able to prove this, but the math works, and the void is exactly where such a scar should be.
And then there's the theory that almost nobody publishes, but that has been discussed in papers and conferences and the kind of late-night conversations that serious scientists have when they think no one is recording. In 1981, the same year the void was discovered, a physicist named Michael Seldner noted that the void's structure, particularly those 60 galaxies arranged in a shell pattern, looked less like a natural formation and more like a cleared space. A Kardashev Type 3 civilization, one that has harnessed the energy of an entire galaxy, could, in theory, manipulate matter on cosmic scales, harvest galaxies, clear regions of space, leave a void behind as a byproduct of incomprehensible engineering. 330 million light years of cleared space. Nobody takes this seriously in print, but nobody can prove it's wrong either.
To understand why the Booty's void matters, you need to understand what the universe normally looks like at large scales. Zoom out far enough, and the universe looks like a vast three-dimensional web. Filaments of galaxies stretching across hundreds of millions of light years. Where filaments intersect, massive galaxy clusters. Between the filaments, voids, empty bubbles of space. This is the cosmic web, the largest structure in existence, built by gravity, dark matter, and 13.8 billion years of expansion. Voids are a normal part of this web. They exist everywhere. They're expected, but they're expected to be small, manageable, maybe 50 to 150 million light years across. The Boötes void is not a hole in the web, it's a hole in the theory of what the web should look like. It's the universe breaking its own rules in public, right in front of us.
Imagine a civilization living inside the Boötes void, on their planet, looking up at their night sky. Our sky has the Milky Way, a blazing river of 400 billion stars, nearby galaxies visible to the naked eye, the Andromeda Galaxy, the Magellanic Clouds, a sky full of company. Their sky would be almost completely dark. No nearby galaxies. The nearest galactic neighbor would be tens of millions of light years away, a faint smudge at the limit of visibility. Everything else, gone. Their astronomers would map the universe. They'd find the cosmic web of galaxies far away, surrounding them on all sides. But in their immediate neighborhood, nothing. Would they even develop cosmology? Would they discover the Big Bang? Or would the emptiness around them convince them they were in a special, unique, perhaps divinely created region of existence? The universe a civilization believes in is shaped by where in the universe they live. We are lucky. Our neighborhood is rich. Our sky is full. Theirs is not.
You might be wondering what would actually happen if you flew into the Boots void. Nothing immediately. Space inside the void isn't dangerous. There's no wall, no barrier, no event horizon. You cross into it and you just keep going. Emptiness all around. The stars and galaxies behind you slowly recede. Ahead of you, nothing new appears for hundreds of millions of light years. Your instruments would show normal space, normal physics, normal time. But looking back, the universe you came from would be getting smaller, fainter, more distant. And ahead of you, nothing. A darkness so complete it'd feel like the universe had ended. There would be no landmark, no reference point, no way to know where you were. No way to navigate except back toward the light you came from. The Boots void isn't a place you go. It's a place you get lost in.
Here's what the Boötes void ultimately asks us. We have built a model of the universe, the Lambda CDM model that explains almost everything we observe. The Big Bang, galaxy formation, the expansion of space, the cosmic microwave background, dark matter, dark energy. It's our best map of reality. And then 330 million light years of nothing says, your map is incomplete. Not wrong, incomplete. There is something we haven't accounted for. Some process, some force, some event that created this void and potentially others like it that our current physics cannot fully explain. The universe is telling us something. We just don't speak the language yet. Remember when I said imagine flying through the universe? In every direction, galaxies. Then nothing. You don't have to imagine. It exists. It has existed for hundreds of millions of years. It will exist long after every star in the Milky Way has burned out. 330 million light years of silence. No stars, no galaxies, no signals, no life as we know it. Just space expanding, cooling, deepening. The universe built everything and then left this one place completely untouched. Or something touched it and left nothing behind. We don't know which, and that not knowing, that gap between what we can see and what we can understand, that's the most honest thing science has ever admitted.
The Boötes void doesn't just challenge our physics, it challenges our assumption that the universe has to make sense to us. Maybe it never did. Maybe the void was always there, waiting for someone to notice it was missing.